What if I told you that in the 1960s, racers were literally dissolving their cars to win, not melting them down, dissolving them, molecule by molecule, in vats of industrial acid strong enough to eat through steel? This wasn't some backyard hack job either. We're talking about factory-backed teams, professional racers, and a chemical process so effective it could make a full-size muscle car lose 250 pounds without removing a single bolt. Picture this. It's 1965 at a National Hot Rod Association event. The tech inspectors are crawling all over a car that just obliterated the competition, running times that shouldn't be physically possible for its weight class. Something doesn't add up. The car looks stock. All the parts are there, but when they roll it onto the scales, the inspectors can't believe what they're seeing. This supposedly 2,800-pound minimum weight super stock car weighs just 2,550 pounds. That's 250 pounds lighter than legally allowed. Roughly the weight of a full-size V8 engine block, just gone, vanished. But the car appears completely intact. The secret? Acid dipping. A process so brilliantly simple yet devastatingly effective that it would revolutionize drag racing, force complete rewrites of the rulebook, and turn mechanics like Buddy Martin, Bill Jenkins, and Dick Landy into legends of automotive subterfuge. These weren't just racers, they were chemists, metallurgists, and rule-bending artists who understood something fundamental. In drag racing, weight is the enemy, and they'd found the perfect weapon to fight it. To understand why acid dipping became the holy grail of 1960s drag racing, we need to travel back to Detroit's golden age of horsepower. This was the era when manufacturers were locked in an all-out war for supremacy on America's drag strips. Ford, Chrysler, and General Motors weren't just building cars, they were building reputations. And that reputation was measured in quarter-mile times. The superstock class was supposed to be for production-based cars. Theoretically, what won on Sunday sold on Monday. But here's where it gets interesting. The rulebook specified minimum weights based on engine displacement and body style. A car with a 427 cubic inch engine might have to weigh 2,800 pounds minimum. Come in under that weight, and you're disqualified. Come in right at the minimum while your competition is 100 pounds heavier, and you've got a massive advantage. The math was brutal and simple. Every 100 pounds of weight reduction was worth about 1/10 of a second in the quarter mile. In a sport where races were won by thousandths of a second, finding 250 pounds to remove was like finding buried treasure. The problem was, there was only so much you could legally remove. No backseat? Check. Lightweight glass? Check. Aluminum bumpers? Check. But even with every legal trick in the book, cars were still coming in overweight. Enter the chemists, or rather, enter the racers who realized they could become chemists. The concept was elegantly simple. Steel contains more than just iron. When automakers stamp body panels, the steel has a certain thickness, let's say 0.8 millimeters for a typical door skin. But what if you could make that steel thinner without changing its appearance? What if you could remove material at the molecular level, taking that 0.8 millimeter panel down to 0.6 millimeter, or even 0.5 millimeter? The panel would look identical, feel nearly the same, but weigh significantly less. Acid dipping did exactly that. The process involved submerging entire car bodies, or sometimes just specific panels, into tanks of hydrochloric or sulfuric acid. The acid would eat away at the steel uniformly, removing microscopic layers of material across every surface. A hood that started at 40 pounds might come out weighing 25 pounds. Door skins could lose 30% of their weight. Floor pans, roof panels, trunk lids, everything got the treatment. Bill Jenkins, who would later become known as Grumpy Jenkins, perfected the art at his shop in Pennsylvania. Jenkins wasn't just dipping random parts, he was calculating exactly how much material he could remove from each panel without compromising structural integrity. Too little acid exposure and you're leaving weight on the table. Too much and your door might fold in half when you slam it shut. Jenkins would completely disassemble a car, cataloging every panel, every brace, every piece of sheet metal. The body would go into the acid bath, sometimes in pieces, sometimes as a complete shell. The process required precise timing. Leave a panel in the acid for 20 minutes, and you might remove 0.1 millimeters of thickness. Leave it for an hour, and you've got Swiss cheese. Temperature mattered too. Warmer acid worked faster, but less predictably. Cooler acid gave more control, but took longer. The chemical reaction was straightforward. The acid would react with the iron in the steel, forming iron chloride or iron sulfate, depending on the acid used. These compounds would dissolve into the acid solution, literally carrying away atoms of the car's body. The bubbling and fizzing wasn't just for show. It was millions of tiny chemical reactions eating away at the metal. Dick Landy, working out of California, took it even further. Landy discovered that different acids worked better on different types of steel. The high-strength steel used in some structural components responded differently than the mild steel used in body panels. By using multiple acid baths with different concentrations and compositions, Landy could selectively remove more material from non-critical areas while preserving strength where it mattered. But here's where it gets really clever. After acid dipping, the panels needed to be neutralized to stop the chemical reaction. Then they'd be treated with phosphoric acid to create a protective phosphate coating that prevented rust. To the naked eye, and even to most technical inspections, these panels looked completely stock. They had the same shape, the same appearance, even the same surface texture. But they were ghosts of their former selves, hollowed out at the molecular level. Buddy Martin, working with Chrysler's semi-official backing, pushed the boundaries even further. Martin figured out that you could acid-dip assembled components, not just flat panels. Entire K-frames, the front suspension cradles, could be dipped. Rear axle housings could be hollowed out. Even engine blocks weren't safe. Martin would dip cast iron blocks in acid to remove material from non-critical areas, turning a 200-pound block into a 160-pound piece of Swiss cheese that still held together at 7,000 RPM. The weight savings were staggering. A properly acid-dipped Dodge Dart or Plymouth Barracuda could shed 250 to 300 pounds without any visible modifications. Front fenders might lose 15 pounds each. The hood could drop 20 pounds. Doors might shed 25 pounds per side. The trunk lid, deck panels, floor pans, firewall, inner fenders, everything got the treatment. Even brackets and reinforcements weren't spared. The results on the track were devastating. These acid-dipped cars were rockets. A 1965 Plymouth Belvedere that should have run mid-11-second quarter miles was suddenly dipping into the low 11s or even high 10s. The power-to-weight ratio was completely transformed. It wasn't just straight-line speed either. Less weight meant less stress on drivetrain components. Clutches lasted longer. Transmissions shifted cleaner. Rear ends survived brutal launches that would have destroyed heavier cars. The competition was in an arms race of chemistry. Ford teams started experimenting with different acid concentrations. Chrysler-backed teams tried exotic acid mixtures. GM racers explored alternative chemical processes. Some teams even experimented with electrolytic processes, using electrical current to enhance the acid's effectiveness. It was like Formula One levels of technical sophistication, but happening in converted barns and industrial garages across America. But this chemical warfare couldn't stay secret forever. That day in 1965, when officials discovered a car was 250 pounds underweight, it sent shockwaves through the sport. How many other cars were illegally light? How long had this been going on? How were they even doing it? The NHRA and other sanctioning bodies scrambled to respond. First, they implemented more rigorous inspection procedures. Cars would be weighed before and after races. Random panels would be tested with ultrasonic thickness gauges. Some inspectors even started carrying magnets to check if steel panels had been replaced with magnesium, another weight-saving trick. But the racers were always one step ahead. They'd acid dip only certain panels, staying just barely legal on total weight while gaining advantages in weight distribution. They'd reinforce acid-thinned panels with hidden internal bracing. Some even developed ways to temporarily add weight for pre-race inspection, then dump it before the actual run. Bags of lead shot hidden in frame rails, mercury in hollow drive shafts that would leak out through tiny holes during the burnout, water injection systems that would spray their entire contents before reaching the starting line. The rulebook became a constantly evolving document. Minimum panel thickness specifications were added. Detailed weight breakdowns by component were required. Cars could be impounded and completely disassembled for inspection. The tech inspection arms race was almost as competitive as the actual racing. Meanwhile, the acid-dipping technology was spreading beyond drag racing. NASCAR teams started using it. Trans Am racers adopted the technique. Even amateur bracket racers were setting up acid baths in their garages. The knowledge spread through racing like wildfire. Magazine articles explained the basic process. Speed shops started offering acid-dipping services. What had been a closely guarded secret became common knowledge. The safety implications were terrifying in retrospect. These acid-thinned cars were running 150-plus miles per hour with body structures that were literally paper-thin in places. A minor crash could result in catastrophic failure. Roof panels that were supposed to protect drivers in rollovers had been reduced to the thickness of heavy cardboard. Door structures meant to provide side impact protection were barely stronger than aluminum foil. There were accidents. Cars that folded up like accordions in crashes that should have been survivable. Panels that tore away at high speed. Structural failures that sent cars careening off track. The exact number of injuries and deaths related to acid dipping will never be known, but racers from that era tell stories of cars that simply disappeared in clouds of sheet metal when they hit the wall. But the performance gains were so significant that racers accepted the risks. This was the 1960s, remember? Safety was barely a consideration. Drivers raced with lap belts and open-face helmets. Roll cages were often just a few tubes of mild steel. In that context, acid-thinned body panels were just another calculated risk in the pursuit of speed. The factories were complicit. While they publicly condemned illegal modifications, behind closed doors they were funding and facilitating the cheating. Chrysler engineers would accidentally leave detailed weight reduction guides at race shops. Ford would ship special racing-only body shells that were mysteriously lighter than production pieces. GM would look the other way when their sponsored teams showed up with impossibly light cars. The technology evolved rapidly. By 1967, the most sophisticated teams weren't just acid dipping. They were using computer calculations to determine optimal material removal patterns. They'd map stress points on panels and selectively protect those areas during acid treatment. Some panels would have graduated thickness, thicker where loads were highest, tissue thin everywhere else. The chemistry got more sophisticated too. Teams experimented with hydrofluoric acid, which could etch glass and fiberglass as well as steel. Nitric acid combinations that worked faster but required extreme safety precautions. Some teams even explored cryogenic treatments combined with acid dipping to alter the steel's molecular structure while removing material. The escalation continued until the early 1970s, when a combination of factors ended the acid dipping era. Stricter safety regulations made the practice untenable. The factories pulled back from racing due to insurance concerns and the 1970 Clean Air Act. The NHRA implemented such stringent inspection procedures that acid dipping became nearly impossible to hide. But the legacy of acid dipping lived on. The techniques developed during this era influenced aerospace manufacturing. The chemical knowledge gained found applications in industrial processing. The weight reduction philosophy became gospel in all forms of motorsport. Today's carbon fiber monocoques and exotic material construction can trace their conceptual roots back to guys dissolving muscle cars in acid baths. Modern racing still obsesses over weight reduction, but now it's done with exotic materials and computer-aided design rather than bathtubs full of acid. A current NASCAR Cup car has every gram accounted for. Formula One teams spend millions to save pounds, but none of them are doing it with the same outlaw creativity as those 1960s drag racers who figured out how to make steel disappear. The specific cars that were acid-dipped have become legends. Surviving examples are studied like archaeological artifacts. Collectors use ultrasonic thickness gauges to verify if their vintage superstock car has original or acid-thinned panels. Those that are confirmed to have period acid dipping command premium prices. They're rolling pieces of racing history, their molecular structure itself telling the story of an era when winning meant dissolving your car. Let that sink in for a moment. These racers were so committed to going fast that they literally dissolved their cars in acid. They turned chemistry into horsepower, metallurgy into elapsed times. They risked their lives in tissue-thin steel coffins that could catastrophically fail at any moment, all for a few tenths of a second in the quarter mile. Looking back, the acid-dipping era represents something uniquely American about our approach to racing. When the rules said you couldn't remove parts to save weight, we figured out how to remove atoms instead. When technology couldn't make engines powerful enough to overcome mass, we made the mass disappear. It was dangerous, probably insane, definitely illegal, and absolutely brilliant. Today's racing is safer, more regulated, more professional. Modern composite materials and computer modeling have replaced bathtubs full of acid and educated guesses about structural integrity. But something was lost in that transition. The Wild West creativity of racers like Jenkins, Landy, and Martin, guys who would look at a car and think, "I bet I could dissolve half of that." That's a spirit that regulations and safety standards have largely eliminated. But maybe that's for the best. Those acid-dipped cars were death traps, their panels so thin you could push your finger through them. The chemicals used were environmental disasters waiting to happen. The racers who worked with these acids often suffered health consequences years later. Progress means leaving some things behind. Still, there's something romantically insane about the whole concept. The idea that winning was so important that teams would literally dissolve their cars. That knowledge of chemistry became as valuable as mechanical skill. That somewhere in Pennsylvania or California, a future Hall of Fame racer was calculating molecular weights and reaction rates to figure out how to make a quarter panel 3 pounds lighter. The next time you see a modern race car with its carbon fiber body and exotic metal components, remember that it all started with guys like Buddy Martin standing over a vat of acid, stopwatch in hand, watching steel slowly disappear. They didn't have million-dollar budgets or computer simulations. They had battery acid, brass balls, and an absolute conviction that every single gram mattered. That's the real legacy of acid dipping. Not just the weight saved or the races won, but the mentality it represented. The absolute refusal to accept limitations. The willingness to explore any avenue, no matter how crazy, to gain an advantage. The understanding that in racing, innovation isn't just about going faster, it's about thinking differently than everyone else. Those acid-dipped cars are mostly gone now, returned to the earth as rust and memory. But somewhere in a private collection or forgotten garage, a few survive. Their paper-thin panels are a testament to an era when the pursuit of speed overcame common sense, when chemistry was as important as carburation, and when making your car disappear, literally, was the key to making your competition disappear figuratively. What's the craziest weight-saving modification you've ever seen or heard about? Drop a comment below and share your own stories of racing innovation, legal or otherwise. If you enjoyed this deep dive into one of racing's most chemically creative eras, hit that subscribe button for more stories of engineering genius and regulatory rebellion. Until next time, remember, sometimes the best performance modification isn't what you add to a car, it's what you dissolve away.